What I'd like to do now is to investigate a little more about this field acceptance test, because a lot of people don't actually conduct a field acceptance test. They assume that everything is going to be operating in accordance with design. That is seldom the case, unfortunately. So what we're going to look at here is what is the difference between the results obtained at site compared to the factory test. And first of all, the design duty provided by the client is generally not in line with what's measured on site. Static and friction losses have not been correctly calculated. The pipe work layout in the test is always optimized. You've got nice long bends, nice long straight lengths of pipe. So there is very little generation of turbulence in the test results you get in a factory test laboratory. And that's because they try to keep the velocities low. So with velocity, you get turbulence. With turbulence, you get irregularity in your gauge readings. Suction conditions are always good in a test bay environment. Suction conditions on site can be questionable. You can have bad suction design, and that will give you trapped air and other problems which may well affect pump performance. The methods of measuring H and Q are usually different on site, although there is a tendency now to use more magnetic flow meters in site measurement, which is, definitely a positive trend. The instrumentation may be different, and the calibration less reliable. And the points of measurement of pressure and flow and speed may be different from those that are nominated in AS 2417 or ISO 9906. And then finally, the driver speeds at site may be affected by the cycles that are generated by that power authority. They're all based on 50 hertz, but if somebody is generating a slightly higher frequency, that will be reflected in the speed of rotation of the pumps. So pump performance is only verifiable in test conditions back at the factory, not based on site measurements. And here's a bit of an indication of what can happen if you choose an operating point that is away from best efficiency point. So here's our best efficiency point. As we move to the left, we start to get discharge recirculation, which appears at the tip of the impeller. We get suction recirculation as the flow diminishes at the eye of the impeller. We're going to start to get impeller vibration in this area. And then we're going to go back to reduced bearing and seal life, again due to excessive vibration. We're going to get low flow cavitation here and high temperature rise as we get closest to closed valve condition. So from here onwards, these are unsatisfactory operating conditions. You don't want to operate a pump in this zone. And that's why I'm saying avoid that operating zone.